Welcome to LNP Renewable System Integrators. Today we are going to see design and the function basics of electrical vehicle part 2. In the last sessions we had seen the part 1. Today we are going to see about the part 2 of 7. Okay, so in this sessions we are going to discuss about how a rechargeable battery works and what are the different types of rechargeable batteries and what is a fuel cell and what are the components of the fuel cell, how a fuel cell works and what are the high voltage components in the electrical vehicle. So if you try to classify the types, okay, we have different types of rechargeable batteries, that is lead acid batteries, nickel cadmium batteries, nickel metal hydride battery, lithium ion battery and fuel cell batteries. And if you try to know about the lead acid battery, it is a 12-volt battery which is used for a vehicle electrical system. Okay, in this one, lead and the lead oxide are used as an electrodes and sulfuric acid will act as an electrolyte. Okay, and if you go for a nickel cadmium battery, cadmium and the nickel components are used as an electrode and the potassium hydroxide is used as an electrolyte. Okay, and next type is that nickel metal hydride battery. So in this one, these batteries are used as a nickel compound and a component of another material for the electrodes, and potassium hydroxide is used as a electrolyte. Okay, it has a high energy density, so that's why we are using this um, nickel metal hydride battery than the nickel cadmium batteries. Okay, and if you go for a lithium ion batteries, so lithium metal oxides and graphites are the electrodes. Okay, we can go for different solvents of the lithium salts as an electrolyte. Okay, and why we are going for this lithium ion batteries? It's very simple. um, it has twice the energy density of the normal lithium nickel cadmium batteries, and also it requires a less space in the inside this electrical vehicle. Okay, so if you try to know about the fuel cell is a cell which produces electrical energy from the chemical energy. In a how a combustion engine works, in the same methodology, it is also use a chemical energy, okay, to produce a electrical energy. Okay, but only efficiency of this fuel cell is that pollution is very less because the outcome in the product is a water. So let us try to know about what is a fuel cell. So for the fuel cell, okay, the most important fuel is hydrogen, which is manufactured in the industry. Okay, what the fuel cell will do, the fuel cell converts this, okay, hydrogen into water with the help of the oxygen from the air. That's it. So what the fuel cell is going to do, fuel cell is the main fuel for the fuel cell is the hydrogen, okay, which will convert the hydrogen into water, okay, using the oxygen which is available in the air. This is how this fuel cell is going to work. Okay, and most importantly, if you compare the hydrocarbon materials, okay, hydrogen is very easy to combust. Okay, and the loss is also very less in the energy conversion process. And most what are the important main components of this uh, fuel cell means, the first component is the nanotubes. Okay, these are the nanotubes which are being made from carbon with a platinum coating. Okay, and the second is the special membranes, and the various components used as an electrolyte. So as we told earlier, we can use any sort of electrolytes, okay, based on our needs. Okay, so the special membrane is a gas type membrane, okay, which is a non-conductive for electrons and permeable for protons. It means protons can pass through it, okay, but electrons cannot enter inside this special membrane. This is how this special membrane is being designed. Okay, oxygen they will take from the ambient air, the existing air. Okay, so how it works, so we have a hydrogen inside the cylinders. Okay, oxygen it will take from the atmosphere, or we can fill inside the cylinders as well. Okay, so what it will do, it will take hydrogen to the anode side and oxygen to the cathode side. Okay, so the hydrogen once came in contact with these um, positions, anode and the cathode side positions. Okay, owing to the presence of this catalyst, immediately the hydrogen will split into two positively charged hydrogen nucleus, that is nothing but the protons. So after getting splitted, what it will do, they will try to penetrate inside this membrane. Okay, as we told earlier, this is a special membrane which allow only the proton to pass through. So through the electrolyte, it will try to pass through this special membranes on the cathode side. So because of this process, okay, what will happen? Energy get created. Okay, so what it will happen? The oxygen absorbs the electron catalyst at this electrode and then immediately react with this free hydrogen protons to form water. So hydrogen and oxygen combining together, they are forming a water as a byproduct. Okay, so since the anode, okay, and the cathode are connected electrically, the current will try to flow because of this reaction. Okay, and if you try to know about what are the high voltage components inside this electrical vehicle, is the inverters. As we told earlier, since our existing motors that we are using, if it is a AC motor, then we need to convert the existing DC power from the battery to AC. Okay, or if even though if you are using fuel cells, okay, the power produced might be in the DC format. So in order to convert that, we need this inverters. Okay, in certain places, these inverters will act as a transducers also. Okay. Next, in certain places, in order to charge the high voltage batteries, okay, we need a DC to DC converter. Why we are going for a DC to DC? Because when some reaction is happening, a power is getting generated. It doesn't mean that power should be in the consistent way. It cannot be consistent in certain places. So for that one, like a diodes, okay, we can go for this DC to DC converters to charge the high voltage batteries consistently. Okay. So the inverters and the DC to DC converters, okay, are combined together inside this power electronics modules. As we told earlier, okay, in order to charge this fuel cells or normal batteries, we need a charging contact. Okay, so inside that charging contact also, we can have the AC to DC converters. So as we told earlier, this high voltage system is separate from the normal 12 volt system of the electrical vehicle. Okay, and also normally in certain places, this high voltage system is referred in orange color because it is little bit high voltage than this normal 12 volt battery systems. Okay. Thank you so much. So if you want to know more and learn more, feel free to contact us. We are providing design, installation, testing and commissioning support for all the industrial, building and home automation projects. And we are providing consultancy supports as well. And we are also providing design, installation, testing and commissioning support for solar projects. Feel free to contact us. In the forthcoming sessions, let's try to see the next parts. Thank you so much.